All right, so this mini lecture is going to look at an example of heat transfer through conduction. So introduce you to the idea of conduction, and then let's look at an example and use it. So heat transfers from one object to another by touching. It can transfer from one object to another by touching. As you will learn as you go through this little series of mini lectures, it can transfer by other methods as well. This one is the one by contact. So we call that the heat transfer conduction. So you have lots of experience with this. You know, let's say you're having a cup of coffee and you pour a little teaspoon of sugar in there and you start swirling around your spoon in that warm coffee, and then you lick your spoon off and it's warmer, right? So the heat from the coffee transferred to the spoon because the spoon was in contact with it. Now, what might affect the heat transfer by conduction? What are some of the things that you think about might kind of influence that transfer? One thing you might suggest is, if you haven't experienced this, which again I'm sure you have, is some things, that spoon got really, really hot, but you can hold that cup and it doesn't feel as hot as that spoon might have got. Different materials conduct heat differently. If you have a styrofoam cup, that doesn't get very hot at all. So different materials. So what affects conduction? One thing is the type of material. And we call this, of course, we have names for everything, right? We call this the thermal conductivity. And we use the letter K. We use the letter K for Boltzmann's constant too, right? And the spring constant in physics 1. So you got to keep tabs on what we're dealing with. But this letter K in dealing with conduction is the thermal conductivity, and that depends on the material itself. What else might affect? Well, if you touch your finger to a hot stove, you get a little burn on your finger. If you touch your whole hand, you feel that there's more heat transferred. So the second thing is the area of the object that the heat is transferring between. That's going to have an influence. And you might expect kind of how big it is. If I have heat between two very long distances, that might influence how much heat is transferred to two different spaces. So the length is going to play a role, or, oops. We might think of this in some cases as the thickness, like the window panes on a piece of glass. That's going to be the example that we use today. And then the temperature difference between the two sides, right? Thermal equilibrium is where we're heading with all of this. And so the temperature difference is going to matter. Okay, so the two temperatures. And when we put all of this together, we get the relationship for the rate of heat exchange, Q over T. Now, energy per time is also called a watt, so sometimes we'll talk about this in terms of the wattage, the rate of heat exchange. We might multiply T to the other side to get the total heat lost in a certain amount of time, but we'll see the relationship as a rate of change of heat is K times the area times the difference in the temperatures all over the length. And we look at kind of the absolute difference in those temperatures, and then we determine heat always is going to transfer from a higher temperature to a lower temperature, right? So we know that from our discussions previously. Okay, so that's our relationship for conduction. Let's do an example. All right, so whoops, I forgot to have the title up there. This is heat transfer of conduction. All right, so let's look at an example. That is not the example we want to talk about. Okay, how much heat is lost in 1 hour if the temperature at a window is 16 degrees Celsius? So right at that window is 16 degrees, and right outside that window is 15 degrees Celsius. It's a large bay window. It has a 2 meters by 1.5 meter size window. The thickness of that glass is 3.2 millimeters, 3.2 millimeters. All right, so how much heat is lost in that amount of time, in that 1 hour? Now, why did I say heat lost? Well, the inside of the house is at a warmer temperature, 16 degrees, than the outside, 15 degrees. And I appreciate those don't seem very big in terms of temperature. We'll talk about that in just a second. So we basically have a plug and chug problem here. So our temperature is what we're interested, how much heat is lost. That's going to be our thermal conductivity of the material that heat is traveling through, glass, times the area of that window, times the temperature difference between the two over how much it has to travel, and that is the thickness of the window, or our distance L, times the amount of time it kind of does that for. So that's our time T. So K in this problem is given. The thermal conductivity of glass is 0.84 joules per second per meter per degree C. Times our area. Well, our area is 2 meters by 1.5 meters, so 2 times 1.5. Our temperature difference, 16 and 15, is 1 degree temperature difference. We're going to go for 3,600 seconds, right? So 1 hour is 3,600 seconds to be in our standard unit. And it is 3.2 millimeters, so 3.2 times 10 to the minus 3 meters. So just kind of keeping in standard units. And we find that our heat is equal to 2.84 times 10 to the 6th joules. All right, so just getting comfortable with the idea of using conduction. When do we use conduction? When we're talking about the physical contact between two objects and heat transferring between them. Now, just a little aside, why is that temperature difference so small at a window in like a house? Because we know the house would be warmer. Well, air is a really good insulator, a really bad conductor of heat. So for heat to transfer from this glass on the other side of the window now through the air to us on the other side of the room is going to be nearly impossible. Okay, it's a really, really good insulator. So very, very little heat transfer. But right at that window is where we get the heat transfer. And we know this experience, right? If we stand next to a window, it feels much cooler than if, if our hands are really close to that window pane, then even through my body, right? Across my body. So how do we increase the thermal insulation of a house with a window? Well, we could do a couple of things. We could thicken the glass. So if I increased the thickness, I decrease that rate of heat exchange. I could add an insulating layer, air, with such a nice high insulating parameter, so very small thermal conductivity between the two pieces of glass. Then I have this coolness right next to the glass with no coolness transmitted to the other piece of glass. So thermal windows have a gap of air in between them to reduce heat loss. So just a little fun fact about energy loss in your home. But when energy is lost with a window, it's not the only way we lose energy in the home. We are dealing with conduction. All right, good job.